So today we have Ray Perrault. He is a distinguished computer scientist at SRI International, and more importantly for this episode, he is the co-director of the steering committee of the AI Index report, which will be out by the time this airs, and it is on its 6th year. So Ray, welcome to the Data Exchange podcast.
Thank you. Nice to be here.
And so actually, before we dive into the report, a few rapid fire background questions. So you have been a computer scientist for many years, mostly at SRI International. And for our listeners who may not be aware, SRI actually has spun off quite a few interesting pioneering AI companies and has many distinguished alums in the industry. But is there a specific field in computer science that you focused on through the years?
So I did my PhD back in the Ice Ages in computational linguistics. And I've been closer to NLP than any other part of AI during my career. However, I spent 30 years as the director of the AI Center here at SRI, where there was a much broader range of AI-related activities done. And so I learned a bit along the way, I guess. But I don't consider myself to be an expert in, many of the subfields that we're going to talk about.
So we are in a treat here because basically the hottest area right now is language. So we will cover that during this podcast. So
right.
First of all, AI Index report. Ray, for those who aren't aware, give us like a very brief description of its goal and target audience.
Yeah. So the goal is to produce what so far has been an annual survey of mostly quantitative information concerning AI in many facets. At the core of it is technical development and publication of AI results, but also increasingly interest in ethical aspects, in policy aspects, in economic implications. In also the kind of growing field of interest in diversity in various ways related to AI.
Do you have an audience in mind when you folks put this together?
Yeah, so I think originally we were hoping that kind of everybody would be interested. I mean, everybody who's interested in AI. We certainly have an audience among policymakers. We talk to policymakers on the side regularly. Jack Clark, my colleague, for example, is a member of a few policy-related boards around the world. So that seems to be having some effect. And the press. So we get cited in the press fairly regularly. The press comes to us as a kind of one-stop source of information about the field.
All right. So before we dive in, just establish kind of the ground truth here. So what are kind of some of the key data sources?
Well, so much of the information in the report comes from outside sources, which are carefully quoted, cited in the report. On Chapter 1, for example, is about publication, and we're now getting most of our data from CSET, the Center for the Study of Emerging Technologies at Georgetown.
Define a publication. Is if I put a paper in archive, is that a publication?
That counts as a publication, but also journals, conferences. I think we even have a section on patents. So we these show up in repositories managed mostly by private organizations, and CSET accumulates these, merges them, and extracts information. And that's one of the, unfortunately, few areas concerning AI where it's relatively easy to get information about the international community, because basically everybody publishes in the same places, whether you're,
Did you mention patents?
Yes.
Patents too. Okay.
And so there are these common repositories for information coming from everywhere. That's much harder to do in areas such as economic impact, and we have now a fairly developed chapter on policy where we look at policies being developed concerning AI around the world. That's work that's being done by a little subgroup attached to the index group, part of the Stanford HAI program. So we've increasingly also been developing content of our own. We have relatively limited resources compared to a lot of big organizations, which is, why we've been getting most of our information from collaborators, many of which have been with us kind of since the beginning.
I'll ping my friend Jaco Savrel, who's over at Zeta Alpha, because they have a lot of these in already indexed using one of these neural search engines.
Yeah.
So all the publications for conferences, patents, even corporate blogs, I think, and code repos. So that might be something. I'm sure he'll be happy to help you guys. But anyway, so if you take a paper has metadata, and so a lot of the things in the report are derived from that metadata, right? So, for example, the institution a person is in, where that institution is located, and so on and so forth, right? All right. So let's go to chapter 1, which is R&D. So obviously, when you look at AI, it's no surprise China and the US are the leading countries in terms of R&D output. So Ray, any countries that stand out outside of those top two?
So there's a lot of activity in some places. The UK,
DeepMind.
DeepMind is, which helps. Singapore, Hong Kong. There are some other places in, some other countries in Asia.
Vietnam is starting to.
That's right. France and Germany in Europe are leaders.
But really, when you look at it holistically, China and the US are head and shoulders above, right?
That's right. I always find it interesting to look at these numbers having some sense of the relative population of these areas. I mean, the US is actually still kind of small by world standards. The population of the US is about half, if I remember, of that of the EU, and the population of the EU is half of that of China. So we don't do, in terms of publications, we don't do any per capita numbers, but I always find it useful to, keep in mind the fact that China's population is enormous compared to that of the US, and it's very well educated, and that shows in their progress.
So you showed that the collaboration between the US and China, was it increasing this year?
So the publications data in the report this year stops in 2021, because we were not yet confident that as of a month ago, the figures for 2022 were really up to, up to snuff. So we're proposing to do a revision of this chapter later on in the year when we're more confident about 2022 numbers. But up to 2021, and so what we're publishing this year is a somewhat revised version of what was in last year's report. It solidifies the fact that collaborations with China have continued to increase. They're not increasing as fast as they used to, but they are still increasing some. And we show the major countries that China has been interacting with.
And another thing that's not a surprise is that industry dominates academia, something
Yes.
that probably our listeners are not surprised about. So you quote, I'm quoting a sentence here. In 2022, there were 32 significant industry-produced ML models compared to just 3 produced by academia. So define significant here.
Size in terms of number of parameters, size of training corpus. Those are mostly the factors we depended on. There's not a lot to learn anymore from small large LMs. The action is all at the high end, and there have been enough results showing that performance significantly increases with size that not many people are developing new ones. Now, there is some very interesting work being done with smaller models in terms of trying to see whether you can get small models to perform as well as larger ones and how you would do that. And we report on some of that.
Yeah. And there's these papers that kind of revisit some of these scaling laws, right?
Correct.
Basically around, you can definitely, as you increase parameters, you get benefit, but maybe you're leaving a lot on the table if you don't train. I hate to call them medium-sized models because they're still 12 billion parameters.
Yeah.
A few years ago, Ray, 12 billion would be considered huge, but now we consider it almost small, right?
Yeah. The other factor in all of this, of course, is the size of the composition of the training set, and that's unfortunately not well known because companies build their own. Companies as a synonym for the builders of large models now build their own, and they build their own training sets.
Yeah.
And they're very cagey about telling you what's in there. There is a core common crawl that everybody uses, but then they clearly acquire information from other sources, and we don't know what that is.
And also, companies like Google, they literally crawl the web every few minutes, so they have so much more. And Common Crawl, as best I can tell, is once every 6 months, so it's quite dated. Now, the Chinchilla paper from 2022 from DeepMind kind of was trying to explore the optimal ratio between compute and data. And there they showed that, again, I hate to call them small models because I think we're still in the 50 billion parameter. Yeah. It's kind of laughable now that we call these, we consider these models small. But that's where we are, right? So we're now in the really ginormous models are in the several hundred billion parameters.
Yes, that's right.
Yeah. And so what's your sense, Ray, of where are we going in terms of model size? Obviously, the companies who can go bigger will go bigger, but one of the things I'm starting to notice and hear and kind of sense is that companies are also interested in building their own custom language models for a variety of reasons, right? Security, privacy, not wanting to rely on a API, maybe not wanting to ship their data across the wire to a third-party provider. And just yesterday, for example, Bloomberg announced that they had trained a 50 billion parameter model in-house. So my sense is that more companies will go in this kind of, I would say, 10 to 50 billion parameter range, but really customize and tune the heck out of it using their own data. So that's one cohort, kind of the custom language models. And then the people who are doing general purpose, the few companies who are going to do that are going to get bigger and bigger. But do you think that there will be kind of a group of people who will start customizing language models?
Yeah, my sense now is, I mean, we've been building larger models for a few years. That the action is really on squeezing more value out of what we have, and there are a number of dimensions in which that's can be done and is being done. The one that I must say I'm finding the most interesting is the development of APIs that allow these models to connect to external knowledge sources and external reasoning capabilities.
Or even vector databases, right? So.
That's right. There's all kinds of ways of connecting these, and we know very little about how well these connections. I mean, they've been announced, but I've not been able to play with any of them yet. So
no, there's tools in the open source that I've been playing with, and they're So I mean, this is why I think that actually more people will be comfortable customizing these models, because they can hook them up, as you described, to their own external data sources. Now, Ray, a few years ago, people were excited about this kind of hybrid neural information retrieval model. So what happened there?
Oh, this is still a very active area, and it gets at some of the well-known deficiencies with the current crop of language models. I mean, as everyone knows, these things have a hard time reasoning. They can kind of interpolate within the data that they've been trained on, but if you try to get them to work outside that data, they fall apart. And some simple things like arithmetic, for example, it's kind of a crapshoot as to whether it gets them or not. The bigger ones get it more often, but it's very hard to depend on the result of any arithmetic calculation that these models do when the numbers get to be at all big. So that and similar problems is I think one of the major open issues, and that's part of what the neurosymbolic people are trying to do, and some of that may be helped by some of the bridges between existing language models and outside reasoners, and there are already companies that are depending on that as part of their products.
Yeah. And I think OpenAI just announced plugins for ChatGPT a week ago, and so now you can integrate ChatGPT with external services. So in the case of Matt, Wolfram Alpha.
Yeah, Wolfram Alpha, I think, is one of the most exciting ones to come on.
But then I think that will be the case for all these large language models moving forward. These external integrations will become more routine. So my expectation is there will be open source tools that will allow you to abstract away the language model so that you can, if you decide to, okay, so for this particular set of use cases, I need this language model or this service, then you can, your code is a little more shielded away from the particulars of the language provider. Now, with that said, Ray, it seems like there still will be a very small handful of companies who will push the size envelope, right? I mean, so these are handful of companies who may be providing general purpose search or general purpose Q&A, I mean, the usual suspects, OpenAI, Microsoft, Google, and some people in China, some companies in China, right? So,
yeah, it's now costing millions of dollars to train one of these state-of-the-art models. Now, millions of dollars is a lot of money for an academic. It's not a lot of money for a lot of companies, and it's certainly not a lot of money for countries. So at the scale at which we're operating now, I think it's still conceivable that more organizations would choose to build their own. I'm quite concerned about the access to this technology to universities and to the budding research community. And there are many issues, about why that's the case. There are movements afoot, certainly in the US and in Europe, to build facilities that would allow universities to do this. There are questions like simply figuring out the dependence of the performance of the model on particular subsets of its training corpus, that, as far as I can tell, can only be answered by building variants on these big models. You just systematically remove parts of the training corpus, you retrain the model, and you do something like that. So there's a bit of that being done in the development and publications related to the current systems, but not a lot. And I think we need to understand better what it is driving the performance of these models, but it's very hard for anyone outside the big companies to do this kind of experimentation now.
Yeah. So chapter 2, technical performance, performance saturation on traditional benchmarks. So first of all, describe very briefly what you mean there, and more importantly, Ray, where do we go from here?
Yeah. So the chapter lists, a few dozen benchmarks that have been developed over the years for specific tasks in various areas, in image understanding and natural language processing and so on. And some of these benchmarks have now been around for almost a decade, I would think, and they've been worked by everybody who's interested in these specific problems. The systems in some of these cases are getting so good that they do almost perfectly on the tasks that are given. For some of these tasks, we have estimates of human performance, though we've actually got people.
So Ray, do you think at some level what we need are new, more challenging benchmarks?
Yeah, and these are coming, and they're coming in different directions. Some is to, for example, combine modalities. So we used to do language and vision separately. And now we have tasks and benchmarks that combine language and vision, so you can ask questions of a combination of an image and a caption, You can generate images based on a natural language input. So these are new tasks.
And then it's so it sounds like based on what you described, it's kind of like summarization that in the end you have to show the results to a human, and you have some kind of panel of humans to assess whether or not you know what I mean.
So that's a challenge. There are tasks of that nature that have been around for a long time, machine translation being one of them, where there's no single right answer. And many of the benchmarks, have very crisp, a particular question has a very crisp answer, and you can ask for that answer, or you can ask for choose one out of four or whatever. These can be graded automatically and quickly. But some of the new tasks, it's more difficult to do that. But automatic measures have been developed for them. For speech recognition, for example, which happens to be one of these tasks where it's not easy unless you annotate every utterance separately. It's not easy to tell what
you need kind of like a clean transcript.
That's right. Yeah. So there are methods. There's a method called BLEU that's used in speech recognition. There are analogous methods for image generation, and they work on the basis of kind of statistical approximations to the training set. So the measures being used for image generation look at the generated image and try to see how close that image is to the corpus. And
so, Ray, for our listeners who are playing around with things like Bard or ChatGPT, for those types of systems, how do people evaluate those systems?
Well, they, in some sense, with difficulty, they evaluate them on some new or actually old tests being applied to these systems. So some of these systems have taken bar exams.
All right.
And so you have a supply of bar exams, you have a supply of answers to bar exams, and you run them. And amazingly, these do pretty well. That does raise the question, though, of do there happen to be bar exams in the training set? We don't know the answer to that. At least I don't know the answer to that.
Right. So, as you pointed out, it can pass a bar exam, but can fail miserably in simple math.
Right.
Yeah.
Right. So you build these.
Which, by the way, some lawyers are in that position as well.
You build these batteries of tests, and you then accumulate the results across these sets of tests, and that's kind of the best you can do on these, unless you start developing new benchmarks for them.
So I guess so. This is an impossible question for me. Might be an impossible question to answer, but at a rough estimate, so what percentage of people and resources are devoted to building and training new models, as opposed to people and resources devoted to coming up with better benchmarks?
I suspect much more of the former than the latter.
Yeah. Although if you come up with a good benchmark like the folks at Stanford and Helm, it does attract attention, and people appreciate that kind of work as well, right? Although obviously, if you come up with a new model, probably a lot more people pay attention to what you just did, right? So
Yes, you'll get many more citations for a new model than for a new benchmark. I suspect that's the case.
Yeah. So another thing that you folks highlighted is AI systems are becoming more flexible. I think we kind of talked about this as you were describing some of these benchmarks, but very briefly describe what that means.
Well, it means building a system that can do more than one task. In the old days, you built a system that tried to identify cats and dogs in ImageNet, and that's all it did. And it was more classes than that, but it was object identification. And now you build systems that do that and 20 other things. The same system is.
Is this observation? Could this observation have been written for the 2022 version of the report as well?
So this generalization across tasks has now been going on for several years. This is not a brand new thing,
right?
But it's clearly important, and it's clearly part of what people see when they play with ChatGPT.
Right. So the other thing in this chapter is that capable language models still struggle with reasoning, which we kind of already talked about. But I wanted to ask you, Ray, I don't know if you saw Google last year. In fact, my friends at Theta Alpha alerted me to this, but some of the most cited papers last year were the series of papers from Google around chain of thought prompting and chain of thought reasoning. So maybe very briefly describe what those are and give us your thoughts about this.
Right. So there's a whole set of practices, experiments one can do with these models that involve essentially teaching the model how to perform a particular line of reasoning by giving it one or a few examples. So think of this as, math word problems followed by a description of how you solved the problem. And so you do a few of these, and then you ask it more questions. This does work. They do learn to perform certain tasks this way. I'm not sufficiently familiar with that literature to know how robust these results are. Whether, for example, you could teach it how to do long addition or long division on arbitrary length numbers, and then it would just know how to do it. My sense is that's still not within the realm of the realm of the possible, but it's clearly part of what's being
and for our audience, Ray, that are not steeped into the details of the terminology. So when people talk of reasoning, is there kind of a precise meaning to that in this context?
Well, it's mostly operations you perform on data using symbolic representations, and anything that you use in, again, solving algebra word problems would count.
So in the context of language models, what are examples outside of math that people normally associate with reasoning?
Well, so there are examples. There's one that my friend Vince Konitzer published or in a talk recently about you talk about a problem where you put objects in a box. You put a few objects in a box. You take some objects out of the box. you take all the remaining objects out of the box. How many objects are left in the box?
I see. And
so there are not necessarily any. I mean, in his examples, there are numbers. So it does involve arithmetic.
So in that example, presumably, if you can chain of thought prompt your way into the solution, then that's a good sign that these systems are starting to reason.
If you can do that. And then, of course, the question is, how many different chain of prompt examples do you need to do? And do you remember them from one session to the next? Can you hand them over to your friend who also wants this capability in his system?
Probably not quite there yet. So another highlight in this chapter is that AI starts to build better AI. And this is more than AutoML that people are familiar with. So describe what you mean by this, Ray.
Yeah, so one of the, hang on a second here.
So, for example, I think you folks cited that Google recently used one of its language models, Palm, to suggest ways to improve the very same model.
Right. So it starts with a question. It generates a number of possible answers. It takes those answers individually. It runs them through the system again. It gets answers back from the system starting from those pieces. And then it does a kind of vote over the overall results. This voting process is something that we're also seeing increasingly in some of these problems. You ask the question several times, and of course, these models being non-deterministic, they will give you a different answer each time, and you see whether these answers are consistent with one another, and you pick the ones that come out most often, and that should improve the reliability of the system. It does not guarantee the reliability of the system, but it should improve it.
Yeah. I mean, I guess the two examples that stood out to me were which is Google used Palm to improve itself, and then the second one has been going on for a while, which is hardware makers like NVIDIA, Intel, and Google are starting to use reinforcement learning for chip design.
Yeah. So reinforcement learning is at the base of many of these examples. It lets you optimize processes, and DeepMind has been involved in particular in a number of these applications.
And the hottest topic right now in large language models is reinforcement learning from human feedback.
Yeah.
Right.
And my guess is that one of the reasons for the release of these experimental systems is to gather feedback data from people like me, who try it out, and you're supposed to click the yay or nay button, and I'm sure that goes back into something useful.
Yeah, and that might become kind of like a mainstream application of RL, but in my mind, it's a lot of it has to do with people being able to design the right user interface so they can gather this feedback. And so, because the feedback is being used ultimately to design a reward function,
right?
But it's a way. I think it's going to be a lot of UX work rather than actual RL work. All right. So then the last chapter there's many more chapters in the book, but obviously we can't talk about them all. The last chapter I wanted to talk to you about was technical AI ethics. So here's a interesting statement from you folks. Fairer models may not be less biased.
Yeah. So there are different ways in which one can measure the bias and fairness of a system. So bias is with respect to particular classes of individuals, race, gender,
Right.
and so on. And fairness is about decisions that are appropriate across an entire group. So if you're making a sentencing decision, or the uses of these legal systems, there one is concerned about how fair the decisions would be. So algorithms are fair when they make predictions that don't favor or discriminate against individuals in a group. And it turns out, and this is sort of fairly tricky, but so to speak, that the performance of algorithms on these two different metrics can be quite different. There are some charts in the report that show that fairness and size align quite well, but fairness and bias don't. And so it's again, we don't quite understand why this is the case, and we even less understand what one could do to change this. There are these previous results that show that bigger models, while they're more accurate, tend to be more biased. They learn more bias out of their training corpus.
Yeah. Maybe the training corpus was biased to begin with. By the way,
well, you're picking stuff up from everywhere.
Yeah.
It's going to be what it is.
Yeah. As you were explaining the challenges, it just struck me as you were speaking that this is why ethics is hard, right? So that's why we have course. That's why we have all sorts of courses on ethics. Now, another thing you folks point out is that automated fact checking with NLP isn't so straightforward after all. But Ray, my reaction there is, who was expecting it to be straightforward?
Well, yes, not an unreasonable expectation.
Because we live in an age where people have alternative facts, right? So anyway, so explain to us what you meant by that statement.
Well, so the first thing is one of the common techniques for fact checking is to look to see whether, if you're asked, is fact F true, to see whether you can find instances of not F in the corpus. And then you bring these together, and if you can see that, well, there are many, many more assertions of not F in the corpus than there are of F, then it's probable that F is an outlier, and it may be disinformation. So that requires a corpus in which there are instances of both, right? And new disinformation, some new random thing, won't necessarily have these counterfactuals in the corpus, and you may not even be able to infer the counterfactuals from the corpus.
Ray, is this notion of PageRank, which is based on citations, although as many people know, those can be gamed. There's a whole industry called SEO that games that. Right? So, but given that, let's say that you control the corpus without a counterfactual, can you just rely on something like a PageRank?
You probably could. That page rank, of course, means you need specific places where the facts occur,
And reliable sources.
and sources that come into it, right?
Yeah.
That cite it, and a a random piece of disinformation on social media
A
probably doesn't
very
have that.
yeah, real time. So here the real timeness and freshness is really the challenge in some
Right,
ways.
right. And real timeness is a significant issue with these models because they're trained on a static training set, and then once they're launched, they are what they are.
So another thing you folks point out, which I completely agree with, is that interest in AI ethics is skyrocketing. But as I pointed out to you in advance of us talking, I just happened to talk to. Oh, by the way, so I advised the first law firm that specializes in AI and analytics, so founded by lawyers and data scientists in Washington, D.C., because that's the only place in the U.S. where non-lawyers can become co-founders of law firms, I guess. So anyway, I happened to talk to them, and they point out that so the one of the areas where there's a lot of systems in place is financial services, but that was driven because of regulations, right? So in financial services, for example, if you do a model or risk model or lending model, then I think by this regulation, you're supposed to set up a completely separate team that does the risk management and auditing and stuff. And
Yeah.
this team is empowered as much as the model builder. So in the case of AI, I think we're in a situation that when it's either the model builders mainly check their own models, maybe they have a red team in some cases, but maybe there's still a power disparity between these two groups, right? So in other words, these folks maybe report to the CEO and these folks report to some VP. So what's your sense of what's going on in industry?
Yeah. So I frankly don't know in the bowels of
Yeah.
these companies.
I'm just speculating. By the way, full
Yeah.
disclosure, I'm just speculating
Yeah.
here.
No, I mean,
What I know is in finance, it's codified that there's
right,
kind of an equal,
right,
they have equal power, right? So
right. And it's pretty clear that there is no such codification for large language models. The There are other AI products that are going to, I mean, or they're going to have to run into this, self-driving cars being the most.
or New York just passed the law around AI models that govern hiring and recruiting, and so
Yeah,
you already have to adhere to those rules. And then
yeah,
EU AI Act, it's a bit vague, but might force another set of actions on the part of companies. But there's this tension between obviously competitive pressure, not just within your industry, but maybe also geopolitically, right? There's a lot of competitive
yeah.
pressure to move forward.
And the geopolitics has broad impact, right? GDPR has had, which is a European regulation, right, has had significant impact in the U.S. Because companies who want to field a worldwide product need to conform to GDPR, and so they will do as much as they can to make sure that their worldwide product is governed by is compliant with GDPR, even though GDPR is not a U.S. Is not a U.S. law. So I suspect we're going to see more of that, but
And in the case of large language models, yes, to some extent, there's still, it's hard to say exactly how much one group really knows more than another group. Is it just a question of that group having more compute resources and more more data, but obviously there's a lot of engineering know-how that goes into building the systems to train these models as well. But you can imagine, right? So if you have some sort of stringent move here in the US, but other countries are free to progress, then the US may say, well, let's unshackle our own companies. So that's what I mean by geopolitical pressure. Yeah.
What I must say I'm, quite fascinated by is what the moves over the next, year of the major corporations who are building these and releasing these models in the US are going to be. And one is already seeing differences in how careful they are about the models that they release. Every one of these models, when released in the first few days, some pretty awful thing has come into the press saying, look, why do they do this?
Because it's they're open-ended canvases in some ways, right?
Yeah, and so clearly one of the things that that may happen is that they may all get better about putting a lid on top of them, and you have to go through the lid in order to use them. But this is already fairly tricky, and as we saw in some of the early cases, people have figured out how to pop the lid. And
yeah. I mean, this is the whole cybersecurity thing, right? So there's always going to be determined attackers, and attacking inherently might be easier than defending, right? So
right,
yeah,
and the raw models themselves are pretty toxic, and so it's then what do you do to control them?
So I guess let me close here, Ray. So right now we're in a state where to really be at the let's say not even the cutting edge, but near the cutting edge, you need to have access to big compute and big data, right? So big compute right now meaning mostly GPUs, TPUs, right?
Yep.
So and are there any signs where there's a little more of a leveling of the playing field? So we talked a little bit about these hybrid neural information retrieval systems that may result into smaller, more efficient models. But do you see any other signs that there's hope for a little bit of, although as I'm saying this leveling of the playing field, does that mean then that a lot more people are free to release really good models, right? So anyway, so leveling of the playing field in terms of are we still going to be completely for the most leading edge models, are we still going to be limited to a few handful organizations?
Yeah. So my hunch is yes, for a while that's what's going to happen. My other hunch is that although expensive, building these models isn't well beyond the scope of Fortune 500 companies.
Yeah.
And a lot of the companies we see doing this are way smaller than Fortune 500 companies. I mean, in some of these cases, OpenAI.
And this is even right now, and we're speculating people may come up with more efficiencies, right? So
yes. So there's efficiencies, and there's kind of controlling the models that we already have and getting them to do more interesting, more useful things. So I think there's a whole field of activity there that if you have access to existing models, you can afford some work. You need smart people to do it, but you can afford the work. And if you
right now, because there's also a lot of startups coming that are going to help companies do this work.
Right. Yeah. That is likely to be there's an ecosystem of we will help you get there.
Yeah.
Yeah.
And with that, thank you so much, Ray.
You're welcome.
This has been great. Thank you.
This has been fun. Thank you.